Okay, this evening we are going to be talking about a quadrilateral hierarchy. Quad as in four, lateral as in lines, and let's take a look here so you can see what that looks like. Here's a quadrilateral for you. It has 1, 2, 3, 4 sides as you see, which make up that quadrilateral. Let's take a second and look at some quadrilaterals. Here in red, we have a rectangle, which is a parallelogram with a right angle. In pink here, we have a rhombus, which is a parallelogram with two adjacent sides congruent. So as you see, these sides are congruent. And then over here, we have a square. A square is a rectangle with two adjacent sides congruent as well. So if you see, they have similar definitions, and you will see why when we get into the properties. Here we have a parallelogram, which is a quadrilateral, because remember those 1, 2, 3, 4 sides, with a, in which we pair of opposite sides are parallel. So these two sides are parallel, and these two sides are also parallel to each other. All right, then we're going to move over here to our trapezoid. And our trapezoid is a quadrilateral with at least one pair of parallel sides. So you'll see that these two lines here are parallel to each other, and these two are not. Now let's take a look at our quadrilateral again. And we're going to focus on the quadrilateral side, which is the trapezoid first. Again, the trapezoid is a quadrilateral with at least one pair of parallel sides, which here you see that those sides are parallel, the legs of equal length, and the bases are parallel but of different lengths. And then I see it's peeking out a little bit there. We have our isosceles trapezoid. Our isosceles trapezoid, as you see, has those two parallel sides, just like our regular trapezoid does, but it's special because these two sides are considered isosceles because they are congruent. These angles are congruent, as well as these sides are congruent to one another. Now let's take a look at our kite. This is also a special quadrilateral. This one does not have any extension off of it. A kite, by definition, is a quadrilateral with two adjacent sides congruent, and the other sides are also congruent. But as you see, these two are congruent, and these two are congruent to each other. Now let's take a look at the big piece here. We have our parallelograms. Now, when we're looking from quadrilateral to parallelograms, we see a few things that are very similar. When we're looking at our parallelogram, we see that this top line and this bottom line, which are sides, they are parallel to each other. And on these sides, which are opposite of those are also parallel. They will never run into each other, even though they are on the same plane. Now, when we look at our rectangle here, we see that we have a right angle. Now, these all interior equal 360 degrees. Now, when we're talking about our rectangle, we see that, again, all sides are parallel and each angle is 90 degrees. Now, looking at our rhombus, we see that all sides are parallel to each other, yes, and we also see that all sides are congruent. But the only difference here is these angles do not equal 90 degrees. Now, if we come down here to our square, what do we notice? We notice that all the sides are congruent. These two are parallel to each other, as well as these two being parallel to each other, and all of our angles equal 90 degrees. Now, because of this, that is why we can say that all squares are rectangles, but not all rectangles are squares. So looking at the quadrilateral hierarchy, I just want you to remember a few things. All squares are rectangles. All squares are rhombuses. All rectangles are parallelograms. All rhombuses are parallelograms. All parallelograms All kites, trapezoids, all of these are quadrilaterals.